Hi everyone, welcome to another episode of 30-day Leetcode challenge. So today's question is you're given a m cross n grid with non-negative numbers. Now you need to find a path from top left to bottom right which minimizes the sum of all numbers. So that means you are standing here and you need to reach this way, this bottom right, and you need to figure out the path which costs minimum. Now you can only move into either a down direction or a right direction at any point of time. Let's look at the diagram to approach this problem uh, algorithmically. Let's see how we can do that. Let me type the input first. So we have 1 here, 3, and then 1, and then 1, 5, and then 1, and then 4, 2, 1. Okay, so my handwriting is getting better, it seems. I'm getting used to the use of mouse. Okay, so now let me circle my start with blue color and destination with green color. This is our destination. Okay, so now I can either move in right direction or down direction, right? So let me draw the output, like how would we traverse. So I am standing at 1. Okay, my cost is at 1. Now when I am at cell this 0, so this is row 0 1 2, and this is column 0 1 2. In order to clearly show it, let me create a cross type this thing here so it will be more clear. So now I am at 1. Okay, now in order to move to cell 0 comma 1, obviously from here, from cell 0 comma 0, I can either go into down direction or I can go into the right direction, right? So while standing at cell 0 comma 1, basically I can either come from left, which is for this direction is left, or from up, because I can move into down or right direction, right, from this cell. But for this cell, when I'm standing here, I would actually be coming either from up direction or from left direction, right? So in this case, obviously I won't be coming from up because it's out of bounds. So eventually I'll be coming from this direction. So the total cost would be to reach here it's 3, and from while coming from the left it's 1, so my total cost will become 4. Similarly, when I am at 0 comma 2, I can either come from up or from left. So basically my cost would be from left, coming left is 4, and here is 1, so 4 plus 1, it will be 5, right? Similarly, when I am at cell 1 comma 0, I can come from up again and from left, but there is no left because left would be out of bounds, so I'll be coming from up. So here this cell has value 1, and while coming from up my cost is 1, so I'll sum it up. Similarly, while going in this direction, I can either come from up or left. So coming in this cell, my cost is 4, and cost at this cell is 2, so 4 plus 2 would be 6, right? Now what will happen when I am at cell 1 comma 1? Obviously I can come from up and I can come from this direction, right? So which direction should I pick? See, at the value at this cell 1 comma 1 is 5. Now what we have to do is we need to minimize the cost of our traversal. So what I would do is I would take a minimum of cost while coming from left, and the minimum of cost, basically minimum out of these two costs. So minimum of left cost plus comma up cost is 2, right? Because 2 is the minimum cost I'll be getting from left. Because I want to minimize my cost, I would avoid taking the up direction. So 2 plus 5 would be 7, so my traversal would be 7. Similarly, when I'm at this cell, I can come from top or I can come from left. which of these is minimum? uh, this is minimum for me, so 6 is minimum for me out of 6 comma 7. So I'll be taking the path from left if I need to reach this cell in minimum time, minimum cost. So cost would be, total cost till reach here would be 8, which is 2 of this cell plus 6 set for the left traversal. So similarly, now for 1 comma 2, what would be my minimum cost when coming from left and when coming from here? Obviously my minimum cost is 5, so 5 and the cell value is 1, so 6. Similarly, when I come from left and top for this last bottom cell, what is the minimum cost of my traversal for the neighboring cells? Obviously 6 is minimum out of 6 comma 8, so I'll be taking 1 of this cell and adding it to 6, so my total cost to reach this bottom cell is 7. Now this is our final go to destination cell, so the value at this cell is our answer, 7, and that's what we get, right? Now as I said, while standing at a particular cell, if I need to calculate its value, so basically if I am at a cell I comma j, basically the cost of reaching I comma cell is the cost itself of that cell I comma j, right, plus I would be taking minimum of my, we saw left and the up cell, which will be cost of up cell would be I comma j minus 1 comma left cell would be okay, my bad, it's for the up, for this is basically for the left cell. So for the left it will be I comma j minus 1, and for the up it will be I minus 1 comma j, right? So this will be my cost of I comma j cell. Basically I can give it an array A. Basically this is my matrix A. So A of A at I comma j plus minimum of whatever cost we have in the upper cell comma the left cell. Similarly, once we have done this for the whole matrix, we just take this as our final n minus 1 m minus 1, which is our final answer. Let's jump into the code if this approach is clear. Okay, so there is no memory constraint they are saying, so let me take separate vector for this cost, and then one more thing to remember here is when I am at a cell which doesn't have either upper cell or left cell, I just take one of them, right? Which is valid one. So I would be doing for I know I 0 comma 0 won't have any cost, so cost of 0 comma 0 could be same, but still I would just iterate, use it in the iteration just to be on the safe side. So I'll do TRAVERSAL, which is a row count, zero dot size, which is a column count. And if you have seen my previous video, I always forget to check the empty grade or maybe empty array, and that's why some corner cases fail. So this would be n, and then I would just use so this is where I'm just initializing my cost matrix, and then if one is greater than or equal to 0, and j minus 1 as well is greater than or equal to 0. That means it's out inside bounds, right? So in that case, my cost of I comma j will be equal to grade of I comma j. The formula we saw, minimum of cost of I minus 1 comma j comma cost of I comma j minus 1. And, so this will be the upper cell and this will be the left cell. Else if this is greater than or equal to 0, so in that case our cost of I comma j will be equal to, because that's the only way to reach the stage, and j else if j minus 1 is greater than or equal to 0. And this else case, I think it's only gonna happen for 0, 0, because for every other cell we are either gonna get I comma 0, I minus 1 greater than or equal to 0, or j comma minus 1 greater than or equal to 0, because this is the only value where we can't come from left and up. For any other cell we can either come from left or come from up, because that's the valid direction we are given in the question, that you can either move in down direction or right direction. So once this is done, I'm gonna return cost of n minus 1, which is basically the cost to reach the last cell. Let's see if this works. It should be 7. Okay, let's submit it. Awesome. Hope you guys enjoyed this video and this was understandable. If so, please subscribe to my channel and give me a thumbs up. Thanks everyone.